Hello, this video is intended for those who already have some C++ experience or some C experience writing sequential programs. Have you ever had a program that you have written sequentially that you wanted to make go faster because it was having issues of taking too long to run? Well, I have a solution for you. And the solution is using a library called OpenMP. You can find more information about this OpenMP library by visiting openmp.org, and you can go to their specifications, and which the current library standard is OpenMP 4.0, but you can get some more information from this website here. Okay? Now, I will go over an example here to show you exactly how powerful this library can be to add to your code. Now, as you can see, this is a nice sequential algorithm, which we have some libraries here. We have some define statements that will be used to time how long our sequential execution takes and how long our parallel execution takes. And we have the sum array here with a random seed, which I'm keeping the same for this example here. And then we got a clear timer, a start timer, and a stop timer, and then a timer elapsed to recognize, how long it takes for this two loops to execute. Okay, this first nested loop is to initialize the values of this array with a random number, and the second one is the one that takes a while, the second nested loop, because of the 100,000 in the inner loop here. Okay, and complex calculation of multiplying the number with the module operators. Okay, so as you can see, this is a nice sequential, it looks like it's going to take a while program. So we look over here, and then in that folder we only have this one file. So I'm going to use the Intel compiler. Now this library does support the GCC, but I have found that the Intel compiler works best for the parallelization. Not to mention it's made for, directly for the Intel's CPUs if you're running this off of Intel. So go to ICC, and then we type in the file name, which is single thread.cpp-o flag, that flag for the output file name, which is going to be single thread, and then I key and enter, and he's got it compiled. So let's try running this, shall we? So we run single thread, and as you can tell, it's taken a little bit of time to execute. And we got a 5.8 seconds to execute. So let's try running it again, just for good measure, see how long this function will take. Okay, 5.7 seconds. Okay, so you can see it takes a good while to execute these two loops. So now what we're going to do is we're going to add 2 or 3 lines of code just to make this faster, using that same library I have mentioned before called OpenMP. So over here we're going to add this library, include omp.h, and that's the name of that's the header file for the library. Now the next 2 lines of code that I'm going to add to here use something called pragmas. Pragma. Now, if you haven't used pragmas before, what a pragma will do is, if your compiler will look over that pragma, and if it doesn't support the instruction that's under that pragma, it will just ignore it. So if, for instance, the Intel compiler didn't support OpenMP, it would still work just as if we had executed it over here before sequentially. But in this case, Intel's compiler does support OpenMP, so this pragma will work. So to do this, what you do is you type in your #pragma, then the standard OMP, then parallel, and then since we're doing a for loop that we're going to parallelize here, the outside loop, we're going to do the word for. Now there's some other parameters you could put here, which you can look at the website to get more information, but for this algorithm, and for just, for first attempt when you're trying to parallelize your code, I recommend just going something simple like this, because you may find that the speed up is what you need. So let's try inserting it down here, same exact line of code. as right up there. So we'll go pragma OMP parallel 4. Okay, so these 3 lines of code, the OpenMP.h, the pragma OpenMP here, and the pragma OpenMP here, and we're going to write that file. So we write the file, it's written, so now we're ready to compile. Okay, so the only difference when you're compiling is you add one more flag. Okay, to include this library, we have to add this flag. This flag is FOpenMP. Okay, as simple as that. So when you key and enter, it compiles for that library. And as you can see, we didn't have any issues when we compiled it. So let's try running this improved sequential program to be parallelized at these 2 loops. When we run it, as you can see, it only took 0.84 seconds. And let's try running it again. And you see it took 0.73 seconds. As you can see, that's about 5 times faster. So you just by adding these 3 lines of code, you already have an application that's running 5 times faster. This video has explained to you how you can speed up your application using the OpenMP library with pragmas, which in this case you only needed 2 simple lines of code to speed up your application.